So, in the previous class, we have discussed about the weathering of soil. In this class, we are going to discuss how the soil is classified depending upon the transportation agents and how the soil is classified depending upon the place of origin and place of deposition. So, let us see. See, always soil, majority of the soil I have told you is caused by weathering only. Okay. So, after the weathering is over, some soils may settle there only and some soil particles may travel along with some medium. So, classification of soil depending upon the transportation agent. Classification of soil depending on transporting agent. See, generally the transporting agent, if for example if you are traveling by bus, you are the passenger of the road transport system. If you are traveling by flight, then you are an air passenger. If you are traveling by train, you are a train passenger. Similarly, here also there will be three modes of transportation basically, that is air, water and ice and gravity. So these are the different transporting agents. We are having. Now, here air means the soil particles which are transported by air. The soil particles which are transported by air are called aeolian soil. If it is water, then again in water there are different forms of water. Water can exist in the form of a river, water can exist in the form of a lake, water can exist in the form of a ocean. So different forms of water creates different kinds of soil. Okay, so this is ocean. So if it is river, then we call it as alluvial soil. If it is river, then we call it as alluvial soil. If it is a lake, then we call it as lacustrine soil. If it is ocean, then it is called marine soil. So likewise, depending on water and different forms of water have different kinds of soils. If it is ice or glacier, we call it as a glacier deposit or glacier soils. Gravity means whenever any rock mass or any soil mass, if it is occurred at greater elevations, okay, somewhere the weathering occurred at greater elevation, then upon gravity they will come down. So that is nothing but colluvial soil. So this is the classification depending on the transporting agents. These are the transporting agents. Okay, and the classification of the soils depending on the different transporting agents we have discussed. Now, here in examination point of view, sometimes they will ask, what are the examples of soils which are transported, which are formed out of the transportation of these transporting agents. Okay, sometimes they may ask. In previous GATE examination, they have asked for 1 mark. Okay, so what are the different kinds of soil examples formed out of this transportation? Because though due to weathering, the soil particles may form, during the transportation at their physical property varies, changes. See, for example, if air is traveling, if air is carrying the soil, air forms a rather uniform structure. It's a uniform air transported soil will have a uniform size. very fine size. If you see sand particles, all the sand particles will be having uniform size. So sand is an example of aeolian soil. So whatever the sand dunes, okay, so the example of the sand is an example of aeolian soils, sand dunes and loises. So this is example of aeolian soil. Alluvial soil, whatever the soil you found on the shore of the river, or whenever there is a flood, whenever flood occurs, flood inundates lot of land. Once the flood recedes, you will find some kind of black, brown kind of a soil. So that is nothing but a loamy soil which is highly fertile, which is having a lot of nutrients in it, which is very suitable for cropping. So alluvial soil example is loams. Lacustrine, generally here also lacustrine you will observe the black and brown only, but in a formative way. See, in lacustrine what happens, alternative layers of silt layer and sand layer, alternative layers of silt sand likewise you will find. So that kind of alternative formation, because lake is a stable, it's a stagnant water, whereas a river is a moving water. That much the arrangement of the layers may not be possible in the river water, whereas lake is at rest always. That is why that arrangement may be possible. So that is why the same thing generally in loams, it is a mixed up of silt, clay, sand and all, but whereas here it is a arrangement, it is a formative arrangement of these layers. Okay, so that is why we call this as a Warwood clay. Warwood clay is an example for lacustrine soil. Warwood clay is an example for lacustrine soil. And marine soils, marine deposits, the example is marl. Whatever the sand you are seeing on the seashore, that is different. River sand is different. River sand comes in this category. Marine sand comes in this category. Marl is an example, marine soil or marine sand or marine clay also. Generally, marine, whatever the rocks are present in the tidal movement of the water of the ocean. So how the soil is forming in marine locations? Because of the continuous movement of tides on those rocks. So wear and tear happens. That is the reason what kind of rock it is wearing off. Depending on the property of the soil will vary. Okay. And ice and glacier deposits, drift or till. So these are the examples of glacier deposits. Okay, generally we found these glacier deposits in polar regions where there is completely covered with ice caps and all. There you will find this kind of soils. Okay, you can find a very whitish soil because it is traveled by glacier. So the color characteristics also varies for those kind of soils. And gravity, that is colluvial soil, example is talus. Talus is an example for gravity soil. So these are the examples are also very important, because in some examinations, not only for GATE, in other competitive examinations also, they will give the list 1 and they will give the list 2. In the list 1, he will ask what is this type of soils, alluvial, aeolian, marine, like this, they will give this part, and in the list 2 they will give this part. So you need to be very cautious about this. You need to remember, because this is very important. In many examinations also they have asked questions from this. Okay, and even in GATE also 1 more questions has come. That is why this is important. You need to remember this. And this is the classification based on the transportation agent. Now, classification based on place of origin and place of deposition. 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 see when the place of origin and place of deposition are different, then we call it as sedimentary soils. Sedimentary soils. For sedimentary soils, place of origin and place of deposition is different. See, place of origin, place of deposition is different for, so they form at one location, they deposit at another location. So that is sedimentary. They forms at one location, they deposits in another location, that is sedimentary. Example, all the kinds of soils except some few. Okay, majority of the soils are sedimentary type only. Very few soils comes in other category, that is residual soils. For residual soil, the name itself says residual. They forms like a residue there itself. They won't move. Okay. So the place of origin and deposition both are same. Place of origin and deposition is same. So that is, here it is different, here it is same. That is nothing but residual soils. So generally, residual is a term by which you can understand that it is a residue form. So that is why generally they won't ask you the name in this format. There is another name for this. That is sedentary soils. So sedentary soils, because see, when it is easily understandable, then that kind of question it will not come. So which you don't know, that question they may ask. Generally sedentary is the term which you may not relate with the residue. So that is why sedentary is a term very important for exam. Okay, sedentary means residual soil. Sedimentary means the soil which is transported and deposited at other location apart from the origin. Okay, now here what are the examples of, because all the soils, majority of the soils which we are seeing all are sedimentary only. Sedentary soils are very few. Let us see the sedentary soils or residual soils. First one is laterite soils. See, laterite soils, how they form. Yesterday I have told you, in the previous class I have told you, what I have told you, when there is any minerals which are present in the rock, okay, if they get settles down, that means if they form precipitates, if they got neutralizes, okay, for example iron is there, iron reacts with the oxygen present in the atmosphere, then it forms iron oxide. So this iron oxide will now becomes a precipitate, and it comes out of the rock, because it is becoming a precipitate. It comes out of the rock, and that precipitate will form a efflorescent kind of, efflorescent why I am saying, because it is having a color. So generally iron is having a color. It is a color, it causes always a red color or pink color sometimes. So this efflorescence, whatever the patches of the precipitate will form on the surface of the rock, when there is any rain, when there is any flowing water passing that rock surface, then whatever the powdered form of efflorescence which is present on the surface of the rock will be taken by that water which is touching it. So that is nothing but leaching. So the water leaches the minerals which are in the form of precipitate and occupied on the surfaces of the rock. So that carries all those precipitates, and it will deposit some at the same location, because the precipitates weight is more, that they won't travel much. So where it is present, there only it will get deposited. Okay, so this kind of deposition is nothing but a laterite. That is nothing but laterite soil. So laterite soils formed out of leaching. It forms due to It forms due to leaching of mineral precipitates such as iron oxide out of a parent rock, out of a parent rock, basalt or trap. So these are the parent rocks, very very important. These are the parent rocks out of which, if the minerals, generally basalt or trap will have more mineral of iron ion, this metallic ion. So this iron oxide, if forms, so this mineral ion will react with the oxygen present in the nature and it forms a precipitate. This precipitate comes out of the rock, leached by flowing water and settles down at the location itself. Okay, the parent rock is basalt or trap, and this is a chemical weathering. If you see, leaching I have kept in the category of chemical weathering. So whatever the laterite soil in which category we can keep it, we need to keep it in chemical weathering. Okay, generally these laterite soils will have a color. So they looks pink or red due to the presence of iron oxide. Due to the presence of iron oxide. So always laterite soils, they looks red color or in pink. Wherever iron comes, iron converts the color into the red color. It may be environment, it may be soil, it may be any subject, it may be brick, it may be cement. So whatever be the material, when iron enters, then it creates a color of red majorly. And sometimes if some other colors are also present, manganese ion or some other ions, some other metallic ions are also present, it will bring some new color out of mixing of 2 to 3 colors. Sometimes here in the laterite case, it is also looks in a pink color, pinkish color also you can see. So this is the chemical weathering part of the rock, basalt and trap. There is a physical weathering part also. For the rock, basalt and trap. The physical weathering of that rock creates or forms a soil called black cotton soil. Out of physical weathering of the basalt and trap rock, okay, so soil which is formed, this is sedimentary soil, residual soil. Similarly, the black cotton soil, this is also formed out of physical weathering of a parent rock, basalt or trap. Okay, it is formed out of physical weathering of basalt or trap. So out of physical weathering of these rocks, this is due to chemical weathering, this is due to physical weathering, this is also a residual soil. It contains more, very very important topic here is the black cotton soil contains a mineral, because predominantly it has a mineral. It is a very fine material. Okay, the black cotton soil is a very fine soil. This black cotton soil contains a mineral called montmorillonite. Okay, a mineral called montmorillonite. It contains a mineral called montmorilonite. Montmorillonite. So this mineral, it is actually a clay mineral. It is actually a clay mineral. Okay. So this mineral generally causes excessive swelling and excessive shrinkage. So what is the nature of this mineral is, it is very thirsty. Okay. It takes more water. How much you give, it will take. As well as it will lose all the water all of a sudden. When the temperature is increasing, whatever the water you have given, all the water will evaporate. So whatever the void space earlier the water is occupied, now it completely compressed down. So you will observe excessive swelling during the absorption of water, excessive shrinkage during the expulsion of water. So the shrinkage and swelling will be very excessive in this soil. Shrinkage and swelling is very excessive in this soil. And actually, though this is a physically weathered soil, but it comes in a category of fine grained soils only. It comes in a category of fine grained soils only. Okay. And it comes in a category of a clay kind of material. Black cotton soil, it is a residual soil formed out of the physical weathering of basalt or trap, but it comes in a category of fine grained soil. Okay. But it comes in a category of fine grained soil because it contains lot of this clay mineral montmorillonite, resulting in excessive swelling and shrinkage. Swelling and shrinkage. So this is the villain of soil mechanics, the most worst soil, the most unsuitable soil for keeping foundations. Okay, the most unsuitable soil for fixing foundation. So here, if you are encountered with this kind of soil, so you are not supposed to keep the foundation there. Okay, so that soil is unsuitable for construction activities. Okay, so that is about the black cotton soil. These are the residual soils. We don't study much about the residual soils because I have told you, because they are residual soils, hardly their depth is restricted for about 1 meter or 1.5 meter only. That means very shallow depths. Generally our foundations, we go up to 4 meters, 5 meters, sometimes it is up to 10-15 meters if it is a high-rise structure. So always we need to know the soil behavior below 15 meter or 20 meter from the ground level, where you don't find the residual soil. Always the residual soil confines to the depth of top 1 meter or 1.5 meter of the earth's crust. So that is why it is not necessary to study about the properties of this soil. Okay, so that is why generally we don't study much about the residual soil, rather we discuss much about the sedimentary type of soils. Okay, so this is the classification based on place of origin and place of deposition. Now what we are going to do is, we will discuss different terms we use in soil mechanics for representing some kind of soil. That means naming. So by seeing for example, everybody, you are having a name. So when I call that name, that represents you. Similarly, soils are also having some names. Frequently occurring soils, we have kept some names to them. So what are the names of different types of soils we are going to understand? What are the names? See, this is a name, laterite soil. Black cotton soil, a name. So we have covered 2 names, and that Warwood clay is one name, sand dunes in one name. So these are all the names. Marl is one name. So likewise, there are many soils. So some important soils names, frequently occurring soil names, we are going to learn now. Okay, so first one is bentonite. Bentonite. See, bentonite is a chemically weathered soil. Bentonite is a chemically, see, montmorillonite will present in 2 soils. One is black cotton soil, other one is bentonite soil. Black cotton soil is formed out of physical weathering. Bentonite soil is formed out of chemical decomposition, okay, chemical weathering, okay. Now first soil, names of different soils. First one is bentonite. See, bentonite, it is formed out of chemical decomposition of volcanic ash. Very, very important. So the bentonite forms out of the chemical decomposition of volcanic ash. Black cotton forms out of physical weathering of rock, basalt or trap. Here it is also having montmorillonite in it. There also it is having montmorillonite in it. So it is having predominantly a clay mineral called montmorillonite. A clay mineral called montmorillonite. See, wherever we find this montmorillonite, that soil is not suitable for foundation activity, because this montmorillonite mineral is the villain of soil mechanics. Wherever you find this montmorillonite, that is unsuitable for laying foundation, okay. That's the same reason, because of excessive shrinkages and swelling, okay. So this is a bentonite. Next is Warwood clay. We have already discussed Warwood clay. That means, briefly I will write alternative layers of sand and silt. Alternative layers of sand and silt. That means, if you observe a lake strata, a lacustrine depositor, the strata on the bank of the lake, you will observe a sheets of a brown sheet. On the top there will be a black sheet, brown sheet of soil, black sheet of soil. So likewise you will observe alternative sheets of soil, brown and black. If you not yet observed, then whenever you go to any lake, you do it now. You do the soil at the bank exactly. You will observe that at the when there is some kind of waves will be there. Though the lake is a stagnant water, though it is having a small waves, very less waves. Okay, so there you will, where the wave is hitting the bank, when the wave is going back, observe what kind of strata you are getting there. Okay, there you will find exactly what I am saying, what is Warwood clay. Okay, now next one is calci. Calci is a conglomerate of gravel, sand and silt. Cemented with calcium carbonate. See, calcium carbonate is having a lime in it. So lime is having a cementing nature. Wherever you find lime, okay, then you will find conglomerization there. Okay. So here also the gravel, sand and silt are cemented with this lime. Okay, so they forms like a small kind of pebbles. Okay, boulders when the size is more than 300 mm. So whatever the soil particles where the size is greater than 300 mm, that is called boulder. Okay, boulders when the size of the soil particle and the size of soil particle is greater than 300 mm, we call it as boulders. Okay, it is called boulders. It is called boulders. Boulders. Next is cobble. 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 Size of soil particle. Size of soil particle. Size of soil particle ranging from 80 mm to 300 mm. Size of soil particle ranging from 80 mm to 300 mm is nothing but cobble. Next, is hard pan. So what is meant by hard pan? Hard pan is nothing but it contains all the kinds of gradations. It is a well graded soil containing all the types of all the sizes of soil. Hard pan. It is a soil which contains all sizes of soil particles, all sizes of soil particles, and very tough to penetrate. Very tough to penetrate during exploration, during soil exploration. See, hard pan is a kind of soil which is like a rock. Simply we can say it is like a rock only, but it is soil actually. So the this hard pan, it is very tough to penetrate, to drive the penetration tools when you are doing the exploration, soil exploration and all. So you need to penetrate this equipment, exploration, for obtaining the undisturbed samples, or for going to some location where you want to find the SBC. So that kind of exploration part, soil finding, soil investigation and soil exploration part is very difficult when you are met with the hard pan. Next is, after hard pan, that is muram. Muram actually the best suitable soil for laying foundation. This is the best suitable soil for laying foundation. It is a mixture of red clay plus gravel. It is a mixture of red clay plus gravel. Okay, red clay plus gravel will forms muram, which is having good amount of safe bearing capacity. Okay, that is why it is very best suitable soil for laying the foundation. It is the best soil for laying the foundation. Okay. Next is muck. It is partly decomposed, organic matter. So it is a chemical organic soil. Muck is a organic soil which is having a partly decomposed organic matter. Okay. Peat, fully decomposed organic matter, that is nothing but peat, fully decomposed organic matter. These are all organic soils. Humus is also one kind of organic soil. Highly fibrous, very fine, decomposed, very finely decomposed organic soil. So general here the organic matter is vegetal matter. If it is a vegetal matter, then peat and muck is formed. If it is a vegetal matter, then peat and muck is formed. If it is any other matter other than vegetal matter, then humus will form. Okay, so these are the different kinds of soils which are little important, which are having little importance in our examinations. Okay, so we have discussed all the important names of the soils which are frequently asked in the examinations. Okay, so this is all about the introduction part. And one more thing we want to discuss here is, so the study, so yesterday I have told, in the previous class I have told that study of the soil mechanics is nothing but hydromechanical aspects of soil mechanics is nothing but the study is nothing but the soil mechanics, and also we call it as the study of soil mechanics, we call it as pedogenesis. So the study of soil mechanics, is called pedogenesis. Pedogenesis is a study of soil mechanics. The other term of soil mechanics is this. And the soil mechanics, the hydrological and mechanical aspects we need to study for the soil mechanics. This was first told by a scientist called Carl Terzaghi. So Carl Terzaghi is a scientist who identified the importance of a separate subject, separate study for soil, because it is not behaving like on the first class I have told you, it is not behaving like a solid completely, it is not behaving like a liquid completely. That is why we need to keep it in other science, that is the soil mechanics. This was first identified by the scientist Carl Terzaghi in the year of 1925. So that is why we call him as father of soil mechanics. Okay, Carl Terzaghi, he is a father of soil mechanics. So as he has suggested, this subject is needed for understanding the soil behavior clearly. So this is all about the first introduction part. Now we are moving on to the next part, that is definitions and relationships between the properties. So soil, I have told you the definition of the soil is, it is having some part of solids in it, it is having some amount of liquid in it, it is having some amount of gas in it. So soil is a combination of all the solid, liquid and gas. Okay, so now how to understand the behavior, interrelationships of these properties, of these different parameters, all these things, definitions and the relationships between the different properties we will understand in the next lecture. Okay, thank you.